Hi, gentlemen. I just want to explain to you the metric prefix chart that you're getting in school to use as a reference chart and how to use it to save some time later. So we already learned about base units. They're down at the bottom of the chart. The meter, the gram, the second, the mole, liter, and Kelvin. You need to know the abbreviations by heart. M, G, S, MOL, capital L, and capital K. But other than that, you'll have this reference chart with you at all times, and you'll have a hard copy of it too. So let's look and see what we have here. So we use this when we want to modify a base unit. So a modified base unit would be like a centimeter or millimeter or a kilogram. Okay, those are ones you've probably heard of. So here are your symbols that you're going to use. Pay attention to the fact that mega is a capital M. Make sure when you're writing it, it looks like a capital M. And when you put it next to meter, that's a small m. Because there's also a millimeter. And there's also this weird Greek symbol here, mu, that represents micro. It kind of looks like a cursive U. I try to slant it a little, make it look like a U with maybe a tail in the front. That way we can tell the difference between your M's and your mu, with the mu, that letter for micro. Okay, so those are the different M's you should pay attention to. Next, pay attention to the fact that some of the exponential multipliers are negative. That means that they are smaller than the base unit. The base unit is represented in the center by 10 to the 0. So that base unit could be any one of the ones listed underneath here, meter, gram, second, etc. See, the exponent for that is 10 to the 0. From math, you should know that 10 to the 0 equals 1. That's why it's 10 to the 0. And we're going to view these exponents like a number line, and that's why I gave you this sample number line here. So the exponents that are greater than, that are positive, are larger than the base unit. Like you might recognize that a kilometer is larger than a meter. Down the bottom here, look at this base unit here. There's where the base, look at the number line, the base unit 10 to the 0 is right there in the middle. So this kind of looks like a number line when you turn the exponent sideways. And so we're going to calculate the exponential distance from, say, a meter to a kilometer. And so on a number line, 0 to 3 is 3 away. So the exponential distance between those two would be 10 to the third. Let's look at from 0, from the base unit to mega. So the exponential distance would be 10 to the 6. It's 6 away. From the base unit to micro, it's still 6 away. So it would also be 10 to the 6, taking the absolute value there. So what if we're going from milli to micro here? So on a number line, from -6 to -3 is 3 away. So the exponential distance would be 10 to the 3. All right, let's try another one. How about from milli to kilo? And we're passing 0. So from -3 past 0 to 3 on a number line is 6 away. So the distance would be 10 to the 6. How about femto to tera? So 15 away gets you to 0, and then 12 more gets you to 27. So 10 to the 27 if we're converting from femto to tera. And I think that's about all that you need to know for this reference chart. All right, see ya.